Good morning. We will start with a new chapter, Understanding Quadrilaterals, Session 1. So before we understand exactly what is a quadrilateral, few different terms what we have to understand in this lesson. That is curve. What is a curve? A plane figure formed by joining number of points without lifting pencil from the paper and without retracing any portion of the drawing is called a curve. Now suppose if I have to draw a star, so what do? I draw like this, 1, 2. What am I doing here? I am not actually lifting my pencil, but I overlapped here at 3 times, correct? That means if I have to lift my pencil, then it is not a curve. A curve is such that which is formed by joining number of points without lifting pencil from the paper and without retracing any portion of the drawing except the point where we have started. That is called as a curve. So we have different types of curve: open curve, closed curve, simple curve and simple closed curve. Let's just understand, not by definition, just by looking at the figures, what are open, closed, simple and simple closed curve. Open curve, a curve which is not closed, which cuts at any 2 points, or we can say here, which is not closed, which is open at 2 points is called as a open curve. So AB is an open curve, this is an open curve. Of course, this is a line segment, but that is also an open curve because it is just cutting at 2 points. Okay. Closed curve, a curve which closes at one particular point is called as a closed curve. Now, see here, this is a closed curve, this is a closed curve, this is a closed curve and this is also a closed curve. Now you can tell me here how this is overlapping. Now if I say this will not overlap because I can start from here, end here, I can come here, come to this point again and come back here, right? I am not over tracing the straight line. Simple curve. A simple curve is a curve which is formed by joining number of points. 1, 2, 3, 4, 5. So there are 5 points which I have used to join this simple curve. Here it is 1, 2, 3, 4 points. 1, 2 points. 1, 2, 3. So a curve formed by joining number of points is called as a simple curve. Simple closed curve, a curve which is formed by joining a single point is called as a simple closed curve. Now among this everything, this is simple closed curve, this is simple closed curve, but not this. Well, these two are example of simple closed curve. This can be asked for definition, 1 mark or MCQs part. So what you have to do now is give the heading as Understanding Quadrilaterals in the same book. Give the side heading as curve. Write down what I have written along with these figures in your book. Now next we will see what is a polygon, what are angle sum properties of a polygon, or how many, based on the number of sides, how do we define a polygon. So what is a polygon? A polygon is a simple closed curve which is made up of only line segments, which is called as a polygon. A simple closed curve which is made up of only line segments is called as a polygon. So we classify polygon based on the number of sides or vertices. So how do we classify them? Now number of sides, classification of a polygon based on number of sides, and what is a sample figure formed when we classify them based on these number of sides. A polygon having 3 sides is called as a triangle. This is the figure. So a polygon will start from 3 sides only. Why not from 2 sides? Read the question. A simple closed curve. Right? That means if I have 2 points, it will be only a curve. It will not be a simple closed curve, right? So it is made up of line segments, which is a simple closed curve. It has to start from 3 only. 2 will form as a only curve. So example is triangle. Now which type of triangle? It can be isosceles, scalene, obtuse, or it can be an equilateral, anything. It's a triangle. 3-sided figure is called as a triangle, which is nothing but a polygon. Excuse me. Four-sided figure is called as a quadrilateral. So that is what we are studying in this chapter. So it is joined by forming four line segments. Which are the different types of quadrilaterals we know? Square, rectangle, rhombus, parallelogram, trapezium and kite. So these are the different types of quadrilaterals what we know, which are joined from these four line segments, and these different quadrilaterals have different properties. That is what we are going to study in this chapter about square, rectangle, rhombus, parallelogram, trapezium and kite. Pentagon, which is formed by 5 points. So this is a pentagon. Now children, figure might not be clear, pentagon onwards. What you can do is, see, you know how to draw a triangle, quadrilateral, up to pentagon, hexagon is very simple, you can do it. Hexagon or heptagon onwards, please look into the figure in the textbook what it is given. So clearly you can draw these figures with respect to the number of sides of a polygon from your textbook. So a five-sided figure or a five-sided polygon is called as a pentagon. Number of sides are 6. It is called hexagon. 7 heptagon. 8 octagon. 9 nonagon. 10 decagon. So on. If I go to n sides, it is called as, I will write here since I do not have space down. You have to write it below. N sides. There is no figure for this. N-gon. Right? So this is called as. Now let us understand how many diagonals will this what do you say? This polygon will have. How do you understand if I ask you how many diagonals the quadrilateral will have? What will you say? Quadrilateral will have 2 diagonals. What do you mean by a diagonal? The line segment joining opposite vertices of a given polygon is called as a diagonal. Triangle, can it have a diagonal? No, because triangle have 3 sides, so it does not have an opposite side. It has 2 sides in the base and 1 is the vertex. So number of diagonals can be formed from quadrilateral. How many diagonals does triangle have? 0. Why it has 0? There is a formula to calculate number of diagonals. Let us substitute that in the number of sides and see where you understand how to find number of diagonals given number of sides of a polygon. Yeah, so you have, after you write the first session, that is the first part, that is curve, types of curve and all, you have to give the heading as polygon, definition, classification of polygon according to number of sides or vertices. Draw this tabular column where you can check the figures given in your textbook, right? You need to write this in your notebook. Few more points. What you have to know here is diagonals. What are diagonals? The line segment obtained by joining the opposite vertices of a polygon which are not adjacent to each other are called diagonals. Suppose if I draw here a square or a rectangle or a parallelogram, these are opposite vertices. These are known as adjacent. This is adjacent to this, this is adjacent to this, this is adjacent to this and this is adjacent to this point, right? So this should not be adjacent, they have to be the opposite vertices. That means I can have 2 diagonals in a quadrilateral. A line segment obtained by joining the opposite vertices which are not adjacent are called diagonals of a polygon. Now since it is a quadrilateral, very simple, you can draw, you can check. Now next will be if you have pentagon, hexagon, heptagon. Tomorrow they'll ask you about decagon. That means you have to draw a decagon, start joining the opposite vertices. Quite difficult to analyze and write. We have a simple formula for that. Number of diagonals in a polygon of n sides. N stands for, of course 3 cannot come. We'll understand why here. 4, 5, 6 and so on is given by n minus 3 divided by 2. First of all, when you draw a triangle, which are the opposite sides here? Now if I talk about these 2, they are adjacent. These 2 are adjacent. These 2 are adjacent. I cannot draw a diagonal because I need to join only opposite vertices but not the HSM. So I cannot draw. Even if here I check in the formula, n is 3, 3 minus 3 is 0. Formula is n minus 3 by 2. Let's check for quadrilaterals. We know that we can draw two diagonals. Number of sides in a quadrilateral is 4. 4 minus 3 divided by 2. 2 ones are 2 twos are. 4 minus 3 is 1. 2 into 1 is 2. We'll check for hexagon. Number of sides are 6. So 6 minus 3 by 2. 2 ones are 2 threes are. 6 minus 3 is 3. We can draw totally 9 diagonals in a hexagon. So this is how we can draw number of diagonals in the given polygon and the formula to calculate this. It is very useful for 1 mark MCQs or fill in the blanks type of questions. Next, we'll understand about regular polygon and a regular irregular polygon. Regular polygon, a polygon whose all sides and all angles are equal are called as regular polygon. Example, regular triangle. What is a regular triangle called as? Regular triangle is called as an equilateral triangle since all the sides and angles are equal. What is a regular quadrilateral called as? Square. All the sides are equal, all the angles are equal. Then we have a regular pentagon, regular hexagon, regular heptagon where all the sides and all the angles are equal. Irregular polygon, a polygon with unequal sides and angles are called as unequal sides and unequal angles are called as irregular polygon. The next is convex polygon. Every diagonal of the figure passes through interior points only. Such a polygon is called as a convex polygon. That means, now look at this, I can draw the diagonals in the interior part, inside this only. A polygon whose diagonals lie in the interior of the polygon is called as a convex polygon. Concave polygon, at least one diagonal of the figure contains a point that are exterior. Look at this polygon. So we can join the opposite side. That means if we can join here, that will become a diagonal. I can also have an exterior diagonal apart from an interior diagonal. At least one exterior diagonal is possible. Such a figure where we can have at least one exterior diagonal is called as a concave polygon. So next we will discuss about angle-sum property of a polygon. We all know that angle-sum property of a triangle is sum of all angles of a triangle, which is 180. Angle-sum property of a quadrilateral when we talk about, so 4 sides, all 4 angles will come up to 360. What about a pentagon, hexagon and any other polygon? How to calculate that? Let us see now. So let us check that. Prove that the sum of the angles of a quadrilateral is 360. I have given it as an angle-sum property. Now see here children, for you know that whatever I write on the board, if it is a derivation, definition or a tabular column, everything you need to write down in your book. Again and again I won't be repeating it in my class. Write down this, write down that. So whatever I have been done till now, everything should be there in your book. Angle-sum property. Prove that sum of the angles of a quadrilateral is 360. Given always, how do you start a geometrical kind of a problems or things here? Your figure should always be to your right hand side and from left hand side you have to start solving this. Please follow this rule. What is given? ABCD is a quadrilateral. Right? What we have to prove? To prove angle A plus angle B, it has to go always cyclic. A, B, C, D. You can't draw A, B and C, D like this. The quadrilateral should always be cyclic. Angle A plus angle B plus angle D is equal to 360 degree. Construction. Join diagonal, any diagonal if you want, join diagonal AC. Whenever you do any construction, that should be shown in a dotted lines only. Okay. So see how I have done here. I started my figure on my right hand side, and from left hand side I started writing. That is how you have to start the geometrical sums. Proof. Now we have to start proving it. Always given will be the question. To prove, you have to see what you have to prove, and to prove the certain given thing, you need to see whether it can be done as it is, whatever is from the given, or some construction is required. So in proof, what we will do now, we have two triangles. So in triangle ACD, I will write now angle D plus angle A. I cannot write because angle A is shared by these two. Angle DAC. You all know how to read the angle. Whatever is the angle that has to come in the center. Angle DAC plus angle DCA is equal to 180. Reason always should be written. What is the reason? Angle sum property. Angle sum property is also written as ASP or angle sum property. Equation 1. Then in triangle ABC, whatever you want to write from a particular triangle, you need to mention which triangle you are writing. Again here, angle B plus angle BAC plus angle BCA is equal to 180. Reason, angle sum property, that is sum of the angles of a triangle is 180. Add 1 and 2. Add equation 1 and 2. So if I add them, what do I get? Angle D plus angle B plus angle DAC plus angle BAC plus angle DCA plus angle BCA is equal to 180 plus 180. Angle D as it is, angle B as it is, DAC plus BAC. DAC plus BAC is nothing but whole angle A. Then DCA, BCA and BCA is nothing but whole angle C. 180, 180 is 360. Rearrange it. Angle A plus angle B plus angle C plus angle D is equal to 360 degree. This is how we calculate some of the angles of a given polygon. Now, these are interior angles of a given polygon. That is, sum of this angle plus this angle plus this angle plus this angle. These are called as interior angles. The angles which lie inside the polygon, what we can say here. So, some of the interior angles of a triangle is 180. Some of the interior angle of a quadrilateral is 360. This is angle sum property which I have proved. Very important one. Now let us see what are the angle sum properties for different polygons. How to calculate. For everything, calculation like this won't be possible. We have a particular formula. Based on that, we apply that for angle sum properties for different polygon. Let's see that. So, these are some basic formulas what you have to know to solve the exercise in the given chapter. Sum of all interior angles of a polygon is given by n minus 2 into 180. Sum of all interior angles. Okay, let me take a triangle now. What is angle sum property of a triangle? We know that it is 180. Let's apply to this and check. Sum of all interior angles of a triangle is 180. We know that, right? Let us apply here. Formula is n minus 2 into 180. So what is n here? N is 3. 3 minus 2 into 180. So 3 minus 2 is 1. 1 into 180 is 180. We got that? Let me try for quadrilateral. Quadrilateral 4 sides. 4 minus 2 into 180. So this is 2 into 180 is how much? 360. We got it? So that is the same thing. We know for triangle, we know for quadrilateral. Very easily we can write. But what if it comes to pentagon, hexagon, heptagon? Apply this. Let me choose a pentagon now. So pentagon is 5 minus 2 into 180. Right? So this is how we calculate. So 5 minus 2 is 3. So 3 into 180. So how much do we get? We get this as 540. Correct? Yes. We get 540. Sum of the interior angles of a pentagon is 540. So what is the formula we apply? N minus 2 into 180. So I'll just erase this, which is not required. That is for your convenient. Examples if you want to write, you can write. But remember this. Second formula. Sum of all exterior angles of a polygon is 360. Now what do you mean by this? Okay. So first of all, let me draw a pentagon. Regular pentagon I am talking about. Okay. So, regular pentagon. Instead of pentagon, what we will do is we will draw a quadrilateral. Much simple. Now when I talk about interior angles, these are interior angles. Sum of all interior angles is 360 here, we know. When it comes to exterior angles, it is sum of this plus this plus this plus this. Here also it is 360 since it's a quadrilateral. What if I take a pentagon now? So I can join this vertex, I can join this vertex, then any other vertex I can join, opposite vertex, I can join here, opposite vertex, I can join here, check if anything, if I have to miss out or anything. All the exterior angles when it comes here is of this part here or from the center when we talk about, or one second. If I consider this and this is the center, what all angles if I get from here, this part. This is called as an exterior angle of a pentagon. That is how I got it forming a diagonal. The same rule I can't apply here. So here, these what I have drawn as a dot, these are exterior angles. What about this? These are interior angles. Okay. Sum of interior angles is this formula. Sum of exterior angles of a polygon, exterior angles remains the same. Whether it is a, even triangle also. Now, if I draw a triangle, what are exterior angles? This is an exterior angle, this is an exterior angle, this is an exterior angle. If I add this and this, I get 360 here, right? Similarly, we get 360 for triangle also. You have this further, we study this further. For pentagon also it is 360, hexagon 360, heptagon 360, anything you take that is 360 only what you get. So they will not ask you in the figure or anything, just you should know this as a formula. Sum of all exterior angle of a polygon is 360, interior angle, this is the formula. If sum of each interior angle, one interior angle and one exterior angle of a polygon, if you add them, you get 180 answer. Last one, number of sides of a polygon if you want to find if an exterior angle is given. That means if one exterior angle is given, you can find that by n is equal to 360 upon that given exterior angle. You will come to know what is the polygon, number of sides you get it. Other way, if they ask you, if they have given you number of sides of a polygon, you can find each exterior angle of a polygon, that is E is equal to 360 by n. So these formulas you should know to solve the further numericals of this chapter. So please make a note of it. With this, we complete today's session on introduction of chapter understanding quadrilaterals. Tomorrow's session will start with the exercise. If you have any doubt in today's session, you can call on the same day of the video set.